Hello students, welcome to E-Pathasala. Myself M. Saravanan, working as Assistant Professor at Kumarur College of Technology. Today we are going to discuss about the module Testing of Woven Fabrics for Special Purpose Properties. Introduction. The module discusses on testing of woven fabric properties, namely special properties which is assessed on a particular modified woven fabric. The woven fabric mainly characterized on the response against extreme factors which makes them unique in certain applications. The value addition properties such as fire resistant, resistant to bacteria, chemical resistance, water resistance, etc. are covered here in this module. Exclusively test methods adapted for those woven fabric. Woven fabric against various factors such as impact, ballistic, UV, etc. and the corresponding test methods are also discussed in this module. Objective of the module. Module aims to discuss the following 3 points and elaborate them in detail inside the module. Number 1. Characterization techniques such as SEM, FTIR for woven fabric when they are subjected to unique chemical addition for special purpose. Point number 2. Resistance to various parameters of woven fabric is touched upon in this module. Point number 3. Test methods for fabric characterized and their efficiency against specific factors are elaborated in this module. Scanning electron microscopy, shortly called as SEM, a normal SEM instrument demonstrating the electron section, test chamber, EDS indicator, electronics console and visual display monitors. SEM utilizes a focused beam of high energy electrons to create a variety of signals at the surface of solid samples. The signals that derive from electron sample interactions demonstrates data about the specimen including outside morphology, shortly called as surface, chemical composition and crystalline structure and the orientation of the materials making up the sample. In many applications, informations are gathered over a chosen zone of the surface of the specimen and a two-dimensional picture is created that clearly presents the spatial varieties in these properties. Areas going from roughly 1 cm to 5 microns in width can be imaged in a scanning mode using the regular SEM technique. Their amplification going from 20x to around 30,000x, spatial resolution of 50 to 100 Newton meter are also possible in this SEM. The SEM also capable of performing investigations of chosen points and areas on the specimen. This approach is particularly helpful in subjectively or semi-quantitatively deciding chemical compositions, crystalline structures and crystal orientations. Fourier transform infrared spectroscopy, shortly called as FTIR. It is a technique which is utilized to get the spectrum of absorption of dyes in the fabric. A FTIR spectrophotometer simultaneously gathers spectral data in a wide spectral range. This presents a huge preferred standpoint over a dispersive spectrometer which measures intensity over a narrow range of wavelengths at once. FTIR is also for the most valuable for distinguishing chemicals that are natural or inorganic. It can be used to quantities and some components of an unknown mixture are also found using FTIR. It can be applied to the investigation of solid, fluid and gases. FTIR is most utilized for distinguishing sorts of chemical bonds, mainly named as functional groups in chemistry. The wavelength of light observed is characteristic of the chemical bonds as it can be found in this spectrum range. Utilizing FTIR, chemical groups are evaluated for the colored specimen. It is also used as a confirmatory test for functional group of a specific chemicals applied for the woven fabric samples. Next is air permeability. Principle used. Air permeability tester works based on the measurement of rate of flow of air through a given area of fabric by a given pressure drop across the woven fabric. Procedure used: take the conditioned specimen and mount a portion between the clamp and circular orifice with sufficient tension to eliminate the wrinkleness, if any can be seen, so that the fabric is not distorted in its own place. Start the suction fan or other means to force air through the woven fabric and adjust the rate of flow of air till pressure drop of 1 cm across the fabric is indicated. Measure the rate of flow of air in cm³ per second. Repeat the test at other different places. At least 10 tests shall be carried for the woven fabric. Finally, calculate the rate at flow of air per centimeter square of a fabric in cm³ per second using a standard formula. Water vapor permeability. Pour around 20 ml of water into each cylindrical box and cover the opening with the specimen to be evaluated totally and seal them with the top lid. The width of the material must be at least 5 mm greater than the corresponding dimension of the fabric aperture. Weight of the tightened boxes and place them in the cabinet and make the total setup run for 6 hours. Expel the containers from the cabinet and note the final weight. From the mean loss in weight and the area of opening in the top of each box, calculate the water vapor permeability for 24 hours utilizing the formula 24 into mass into time divided by area of the specimen, which is given by the unit gram per meter square per day. Fabric impact strength. The given samples of fabric are prepared. Before testing, the instrument needs to be adjusted without any sample on the pendulum for calibration. The pendulum is dropped from the catch by keeping the pointer in vertical position. If the pointer shows 0 on the scale when moved by pendulum to the other side of the machine, it is said to be adjusting. If not, the catch which catches the pendulum has to be raised or lowered till the pointer shows 0 when the pendulum is released from that position. The pendulum is raised to the catch on the right hand of the quadrant and kept in position, and the pointer is placed near to the anticipated braking position. The fabric to be tested is secured to the base grip and grip on the pendulum bob in the proper way without any twist in the fabric. The catch is then released and the pendulum swings to the other side, pulling the sample, and also the pointer rises to a height and ruptures the woven fabric. The position of the pointer reads the energy spent in rupturing the sample in inches pounds. The total experiment can be repeated for the woven fabric samples to a number of 5 quantity, and the total mean is calculated. Water repellency. The procedure used for water repellency is the test specimen, which is woven fabric, can be secured in 152 mm metal hoop so that it presents a smooth wrinkle free surface. Place the fabric on a stand of the tester with the fabric face uppermost in such a position that the center of the spray pattern coincides with the center of the hoop. In case of twill fabric, gabardines, picous or fabrics of similar ribbed construction, the hoop placement on the stand in such a way that the ribs are diagonal to the flow of water running off the fabric specimen. Pour 250 ml of distilled water in a standard temperature 27 degrees Celsius plus or minus 1 into the funnel of the tester and allow it to spray onto the test specimen in a span of 25 to 30 seconds. Avoid touching the funnel with the beaker while pouring the distilled water. Movement of the funnel will alter the spray disposition on the specimen. The spray time must be between 25 to 30 seconds. Otherwise, the nozzle should be checked to see if the holes are enlarged or blocked. Take the hoop by one edge and tap the opposite edge smartly once against a solid object so that the fabric facing the object, then rotate the hoop 180 degree and tap once more on the point previously held. Those steps can be repeated for all the woven fabric can be evaluated. Weather resistance. The water in contact with the test specimen is regulated at 21 plus or minus 2 degrees Celsius. The fabric can be clamped. The specimen with the surface to be tested need to face the water. Turning on the motor, press the lever to raise the overflow devices at the rate of 10 mm per second and close the air vent as soon as water flows from it. Disregarding water droplets that appear within approximately 3 mm adjacent to the edge of the specimen clamping ring, record the hydrostatic pressure at the movement of water droplets that penetrate the fabric at least in 3 different places. Water absorbency. Absorbency is usually measured in seconds. The method which is described in this module designed to measure the water absorbency of textiles, mainly woven fabric, by measuring the time it takes a drop of water placed on the surface of the fabric to be completely absorbed on the sample. Sample is placed over the top of a beaker so that the center is unsupported. A measured drop of water is placed on the fabric 1 cm from the surface. Parallelly, time is recorded until the water drops absorbs completely on the fabric surface. The amount of water absorbed is expressed in percentage and then it is calculated. Next is ballistic limit testing, usually termed as B50. Ballistic limit protection, B50 BLP, is a short form. It's expected to assess armor material by testing either a single sample or numerous samples in the same time. The test depends on the Brewston method for assessing a non-quantifiable response to a variable stimulus. To give an example, a match ignites or does not, a light flashes or does not, and so on. These no, go and go comes about utilized to build up a 50% probability of armor efficiency and the penetration aspect. The full penetration curve can also be given. B50 values depend on the average of equivalent quantities of velocities related with complete penetration and partial entrances. The quantity of velocities required to decide the B50 esteem value is need to be specific so that counteract skewing of the outcomes. Most minimal velocity related to a complete penetration and most elevated velocity associated can also be explained. B50 testing strategies for helmets regularly require the protective clothing, namely woven fabric, is divided into 5 segments in different places of the parts, namely crown, front, back, left and right sides of the body part, to compute the B50 value by a appropriated in the fabric samples. Another testing for the armor materials is residual velocity testing. It is a testing expected to decide the resistance of a protective layer and its ability to resist the penetration. Residual velocity is usually given by the formula V suffix s minus V suffix r, is different from the V50 testing, which is explained earlier in the module. The V50 testing is led with an unbacked armor sample, while it is not so case of residual velocity testing. Velocity computing instrumentation situated behind the armor sample is added to the V50 test, and the residual velocity is compared with the striking velocity, namely VR compared with VS, for each piercing shot of the armor material. The residual velocity is utilized to survey the level of lethality to be expected from ballistic dangers whose speeds surpass the level of protection of the woven materials. Flame resistance. It is a standard method for assessing the woven fabric, which is given with the special value addition. It is determined by vertical flammability test. The durability of flame retardant is important to its washing capacity. Firefighters who have less permeability due to heat stress, maximum time of wearing should be given the priority. Furnishing fabrics have no such worry like the firefighters because comfort is so important. It is important to test fabrics to ascertain if they are likely to be suitable for the application for which they are required. ASTM and BSI methods are available for such tests. In some cases, ISO standards also exist for the flame retardant testing. Both ASTM and BSI have a vertical specimen test for fabrics for thermal protection. ASTM D3659 resembles BS3119, which has been virtually replaced by BS5438. The procedure is, if the fabric ignites, these tests can determine the spread of flame and the burning rate. Woven fabrics for thermal protection should not ignite. So the other aspects are not needed and not considered in this testing. Test to determine the critical oxygen content of textiles named as LOI are given by the ASTM D2863, which is identical to the method BS2782. The second group of test for the same flame retardant of woven fabrics is given by ASTM D4108 and BS3791. ISO method is also available for the flame retardant whose standard number is 6942, is mainly for gas heated radiant panels. The ASTM test uses convective heat while the ISO test uses purely radiant heat. Another conventional and upcoming test for flame retardant is limited oxygen index tester. It is usually called as LOI. It is the percent concentration of oxygen at which a small sample will just burn downwards in a candle-like manner. The test is likely the most surely understood of the standard fire test. The device holds a little sample of material which is gripped vertically in a tube in an environment where the relative concentration of oxygen and nitrogen can be changed. The point is to test the flammability of the sample with a little pilot fire to determine the maximum oxygen concentration required to simply manage burning of the woven specimen. The woven fabric is placed vertically in a glass chimney and an oxygen or nitrogen condition is set up with a flow from base of the chimney. The top edge of the woven specimen is ignited and oxygen concentration in the flow is diminished until the point when the fire is no longer supported. Oxygen index in percentage is computed from the final oxygen concentration tested. The test results and the woven fabric samples under the conditions of suitable defined test methods is an outcome measured to infer the fire risk of the woven fabric in different forms. Vertical strip test. It's a test method has accomplished the most extensive acceptance for deciding the flammability. It is based on British standard BS 5438. It depicts the test technique for measuring ease of ignition and rate of fire spread of vertically mounted test specimen. A predefined small butane flame is applied to the bottom edge of a vertical woven sample which have its dimension 200 mm long and 80 mm width for prescribed times, and the minimum start time is noted. This test gives the fire resistance to the woven fabric samples for 10 seconds to the bottom edge of a vertical mount sample, and the fire spread times are measured by recording the severance of the marker threads in seconds. Next comes to the chemical protective cloth. Assessment of various types of tests for chemical barrier is classified into three. Number 1, test for assessing degradation resistance. Number 2, test for assessing penetration resistance. Number 3, test for assessing permeation resistance, degradation resistance. It is a test again classified into different types, namely immersion technique, one-side exposure technique, and finally solubility based evolution. Immersion based. ASTM D471 is a suitable test method applied for the woven fabric. It is usually taken place for 22 to 760 hours in 5 different immersion periods, and the temperature applied to the testing is 72 degrees Celsius to 250 degrees Celsius. Another method, ASTM D543, used for same degradation resistance, is valid for 7 days, and temperature applied in this test method is 50 to 70 degrees Celsius. Usually in degradation resistance, change in weight, change in volume are observed and noted. One-sided exposure. It is another degradation resistance measurement for chemical barrier fabrics following the ASTM F1407. Here again the weight changes after the exposure is measured. Depending on weight loss, the woven fabrics are graded. Weight loss of 0 to 10% is excellent. If the woven fabric is 11 to 20% weight loss, then it is classified as good. If they are 21 to 30% weight loss, those fabrics are rated as moderate, and more than 30% are rated as poor. Weight loss may occur due to degradation, but a gain also occur. This may be due to absorption or adsorption of chemicals on the woven fabric. The last one for chemical protective fabrics are solubility parameters. ASTM D3132 is a standard test method for solubility parameter, follows the simple procedures. Material is immersed in different chemicals damage is assessed. Solvents with nearly solubility parameter of the woven fabric. Once unknown solvents solubility parameter is known, we can judge the effect on the fabric. Penetration resistance. ASTM defines flow of chemical through closure, porous materials, seams and pinholes and other imperfections in a chemical protective clothing. They are given by different methods. The first method is runoff based method. Specimen is kept at inclined position and chemicals made to run off. They follow AATCC 42, AATCC 118 and ISO 6530. Hydrostatic based. Liquid under pressure is made to come in contact with the woven fabric. Here it follows AATCC 127 and ASTM F903 standard methods. Next comes to the UV protection of woven fabric. UPF is the common factor estimated for the UV protection of woven fabrics is given by the AATCC test method 183 UPF value calculation. In Vita method is used to assess UV protection of woven fabric as per AATCC 183. It measures the transmission or UV blocking of UV radiation through fabrics by UV VIS spectrophotometer. The UV profiles of the woven fabrics are compared with the spectra collected from the same woven fabric which are treated and untreated. UV radiation is evaluated by measuring the UV protection, transmission and reflection. Each measurement is average of 4 scans obtained by rotating the sample for about 90 degrees Celsius. The transmission data is used to calculate the UPF value with standard procedures. Self-cleaning actions. The self-cleaning activity of the woven fabric is assessed for treated samples, mainly using the chemicals. By exposing the samples containing adsorbed coffee stain to visible radiation. The measured quality of 6% coffee solution is introduced on the woven fabric and time allowed to spread on the surface of the fabric. 1/2 of each stain on the fabric is exposed to sunlight for 12 to 48 hours, while the other half is covered with a black paper to prevent its irradiation from sunlight. The exposed part of the stain is compared with that of covered part for self-cleaning action. Premier color scan spectrophotometer is used to measure the change in K by S value, where K is absorption and S is scattering. The self-cleaning property of the cotton fabric in particular is analyzed and reported in a graphical form. The percentage of decrease in K by S value for the exposed samples is usually noted and evaluated. Antimicrobial testing. Testing for antibacterial action of woven fabrics which are specially treated by the natural or chemicals. It is carried out using a qualitative method described in the standard AATCC test method 147, shortly called as disc diffusion method. In this method, Mewell Hinton agar solution is prepared by dissolving the Mewell Hinton agar of 38 gram per liter and nutrient bond of 13 gram per liter in distilled water of 1000 ml, and they are taken in a funnel shaped conical flask. The flask is subjected to autoclave at 120 degrees Celsius for 20 minutes. Sterilized Petri plates are used with equal thickness of Mewell Hinton agar medium. The swabs, mainly by cotton, are used for swab sticks. The treated woven fabrics, usually by natural or synthetics, taken in disc shaped of diameter 1 cm are kept on the prepared medium. After incubation, the antimicrobial action is assessed by measuring the inhibition zone of diameter observed on the Petri plates. Another test method for antibacterial testing is drug release through UV spectroscopy. Drug release test using basket USP apparatus or conventional one using the dissolution procedure can be applicable for single or total products at a motor speed of 75 and 100 rpm. The sampling of liquids of totally 5 ml can be taken at 0 to 60 minutes interval. At each time, it can be toppled with equal volume of fresh medium to maintain a constant total volume of 5 ml. At end of each test time, samples are filtered, the aliquots are diluted in dissolution medium when necessary and quantified. The prepared liquids are validated by spectrophotometric method and the contents results used to evaluate the % release on each time of dissolution profile. Phosphate buffer with a pH of 7.0 and 0.75% of sodium lauryl sulfate. This solution medium are used mainly for specificity, linearity, precision and accuracy as per the ICH guidelines. All observance values are noted down at 460 nanometer. Acoustic protection. Standard wave apparatus is commonly used to determine the acoustic property of the woven fabric. They are able to measure the coefficient of assimilation of the given acoustic sample, plot them in a injection coefficient as a component of recurrence. The apparatus is mechanically assemble chips away at the standard, accomplishing how much the wave looks like either an unadulterated standing wave or an impeccable voyaging wave, and they are described in standing wave ratio named as SWR. SWR is proportion of the plentifulness of a halfway standing wave at an unfriendly to center point. SWR constantly has a regard of significant identification to solidarity of the solid samples. It is used to choose the reflection co-beneficial abundance noted as R, assimilation coefficient noted as alpha, and impedance noted as Z of any acoustic specimen, and those values are compiled for total evaluation of the acoustic property of the woven fabric. Thermal protection. The thermal conductivity of the woven fabrics is assessed by Lee's disk method. The fabric sample of unknown conductivity is put between two specimens of known conductivity. Usually brass plates will be used in this experimental method. The setup is normally vertical with the hot brass plate at the top, the specimen in the middle supported by the cool brass plate at the base. Warmth is provided at the top and made to move downwards to stop any convection inside the sample. At last, it is ascertained by the simple formula K equal to M into S into D square bracket R plus 2L square bracket dQ by dt, total value divided by the pi r square multiplied by square bracket 2r plus 2l multiplied by C1 difference C2, where M stands for mass of the disc used, S stands for specific heat of the material of the disc, D stands for thickness of the woven fabric, R stands for the radius of the disc, L stands for the thickness of the disc, C1 and C2 are temperature of steam in degree Celsius. Let me conclude from the module what discussed. The module summarizes the response behavior of woven fabric for damage that might be expected in actual usage, mainly the wear and tear properties. The module concludes on test methods usually evaluated for woven fabric, mainly for specific applications. The specific applications are obtained by modified woven fabric using different treatments, namely chemicals, gaseous and other methods. The uniqueness of specialty woven fabrics are assessed in this module against extremely conditions, and the responses are included in this module. The module also summarizes the various protective measurements such as ballistic, fire resistant, and their characterization using FTIR, SEM are also discussed in this module. The module elaborates the key methods mainly used for the treated as well as the untreated woven fabrics, so that its efficiency of the process, namely finishing methods, coating methods, are also described in this module.